Hey there. So in this video I have another problem for you from the Creative Math Solving page over on Instagram. So you can check out his page for a different solution to this problem from mine. And now let's get started. So the question says A, B and C are natural numbers and there is a strict ordering on them, C greater than B greater than A. So A equals B equals C is not allowed. And we want ABC minus 1 to be divisible by A minus 1, B minus 1, C minus 1. And right off the bat, you can intuitively tell that there must be an upper bound on the value of A, B and C such that this divisibility will hold, because if you keep increasing A, B and C, as they get bigger and bigger, A minus 1, B minus 1, C minus 1 will keep getting closer and closer to ABC. But at the same time, it can never equal ABC minus 1. Why is that? We'll see that later. But just take my word for it for now. A minus 1, B minus 1, C minus 1 can never equal ABC under these conditions. But if they can never equal each other, that means that there will come a time when A minus 1, B minus 1, C minus 1 will become too big to be a factor of ABC minus 1. But hold on, you might say, if this is always less than this, then how can this be too big to be a factor of this? Well, let me show you. I want you to list the factors of 24. So it's a quite easy exercise. It's 1, 2, 3, 4, 6, 8, 12. And then, is there any factor greater than 12? Well, yes, there is 24. But is there any factor between 12 and 24? No, right? But how can you be certain about that without even thinking about it? We have an intuitive notion that the greatest factor of 24, which is not 24 itself, can be 24 by 2, right? Because any factor of it is of the form 24 by n. And if this is an integer, then this is a factor of 24. Well, n is also an integer, so n is either 1, so this is equal to 1, or it's greater than or equal to 2, right? That's pretty obvious because it's a natural number. So it's either 1 or it's greater than or equal to 2. But then that means that any factor of 24, which is not 24 itself, is less than or equal to 24 by 2. So if this becomes greater than this by 2, then we can be certain that it's not a factor, because we already established that this is not equal to this. I'll leave the proof for that to you. So now that we have this settled, we can make an inequation from this, and maybe we can restrict the values of A, B and C, because as I said in the beginning, there must be an upper bound to A, B and C. So for example, if I take arbitrarily large values for A, B and C, let's say 756 and 892 and 1024. So just by looking at these values, you can straight away tell that this can never satisfy this condition, because these numbers are just too big for that. So maybe we can find an upper bound using this inequality right here. Okay, so here is our inequation, and you can see if this matches up with what we discussed before. And now we can expand this, and you can already see there is going to be an ABC term in the expansion, so we'll get some cancellations, which is always good. So we get ABC minus AB plus AC plus BC plus A plus B plus C minus 1 is less than or equal to ABC by 2 minus half. So cancel that with that, we get ABC by 2 on this side, and on this side we get half. So now we can move this and this to the other side, and also this. So we'll get ABC by 2 is less than or equal to AB plus AC plus BC minus A plus B plus C plus half. And now what we'll do is we'll divide out by ABC. But then you might say that it will give us fractions on both sides, and fractions are not exactly something you want in Diophantine equations, do you? But still, I'm going to tell you that it's going to work, okay? So just trust me on this. Let's divide out by ABC. ABC is always positive, so we don't need to worry about changing the sign. So we get 1 by A plus 1 by B, 1 by B plus 1 by C minus 1 by AB plus 1 by AC plus 1 by BC, and I'll take this inside the bracket, so we get minus 1 by 2 ABC. But now notice that A, B and C are all obviously greater than 1, so that means a plus b plus c is greater than half, and I can also rewrite this as minus half like that. And now since this each one of these is greater than 1, this entire thing must be greater than 3, and if it's greater than 3, this entire thing is positive. So if this is positive, then this divided by ABC is also positive, so this is strictly greater than 0, it's positive. But now notice that if we take this to the other side, then I'll just cancel it out like that. Let's say this entire thing is equal to some number k which is positive, so we get half plus k is less than a plus b plus c. But now k is positive, so this is greater than half, so what we get is 1 by a plus 1 by b plus 1 by c is strictly greater than half. And now we have finally arrived at the condition which will limit how big a, b and c can get. So let me show you how. We know that b is greater than a, c is greater than a, so that must mean that 1 by b is less than 1 by a and 1 by c is less than 1 by a. So that means that this is strictly less than 1 by a plus 1 by a plus 1 by a. So that is equal to 3 by a. So we get that 3 by a is greater than half. So if we cross multiply, we get a is less than 6, which means a is less than or equal to 5. But notice that a can't be equal to 1. So if a is equal to 1, then this entire thing is 0. So we'll be talking about divisibility by 0, which of course is not possible. So what we get is 4 cases: a equals 2, a equals 3, a equals 4 and a equals 5. So if we check all these 4 cases, we'll be done. So here is the first case on our list, a equals 2. So now I'm going to tell you that this statement must imply that 2bc minus 1 over 3 is strictly greater than or equal to b minus 1, c minus 1. And now the proof for this is left to you, but the hint is that there can be no factor of 24 other than itself which is greater than 12. So now let's get started and see where this leads us. So this is bc minus b plus c plus 1. So if we use that, we get minus 1/3 is greater than or equal to bc by 3 minus b plus c minus 1. And now we can bring this here to make this 4/3, and this is going to be a similar case as the first inequality. So in this case we'll get 1 over b plus 1 over c is greater than 1/3. I'll leave the proof to you. And now what we'll do is we'll say that c must be greater than b, so that means this must be less than 2 over b. So that means 2 over b is strictly greater than 1/3, which implies that b is strictly less than 6. So that means b is less than or equal to 5. So now we get further 3 sub cases. B equals 3 because b can't be less than or equal to a, and b equals 4, b equals 5. And then for each of these cases, once again you can find an upper bound for c and you can find out which of them give you a solution and which of them don't. But now I'm going to leave that to you, and I'm going to tell you that from here we get the solution 2, 4 and 8. For the second case where a equals 3, once again we get this inequality. I'll leave the proof to you. And now this tells us that 3/4 bc minus 1/4 is greater than or equal to bc minus b plus c minus 1. And once again we can do the same thing, bc by 4, and this time we'll get the inequation 1 by b plus 1 by c is greater than 1/4. From here we get that b must be less than or equal to 7. And of course you can tell that there are a lot of cases which we have to deal with, because for a equals 3 itself we have to deal with b equals 4, 5, 6, 7, and after that we also have a equals 4 and a equals 5. So there are a lot of cases which we have to deal with. But I'm going to leave all of that to you, but I'm just going to cover one case where a equals 3 and b equals 5, because this case is one of the harder ones to deal with, and if you can deal with this one, then you can deal with all of the others. So it's just manual labor at this point. The intellectual part is over. So I'll just show you how to do this particular case, and after that, if you are curious, you can do it on your own, but I'll tell you all the solutions, don't worry. So now let's get started. B equals 5, so we get ABC minus 1, so that means 15C minus 1 over A minus 1, B minus 1, C minus 1, so that is 8, C minus 1 is a natural number. And from there we can tell that if I write this as 16 times C minus 1 plus 15 minus C, you can check that these two are equal, then we'll have 2 plus 15 minus C over 8 times C minus 1 is a natural number. And now what we'll do is we'll say that this is equal to some k, and k is a natural number. So we get that k minus 2 times 8 is equal to 15 minus c over c minus 1, and we can also write this as 14 over c minus 1 minus 1. So now if we move the minus 1 to the other side, we get k minus 2 times 8 plus 1 is equal to 14 over c minus 1. And now notice that the LHS of course is an integer, so this also must be an integer. So what must c minus 1 be equal to so that this is an integer? Well, it must be a factor of 14, so that means c minus 1 equals 1, 2, 7 or 14, and we can check for each value of c whether this condition is satisfied, because this is basically saying 14 over c minus 1 is congruent to 1 mod 8. And I'll tell you that the only solution for this is c equals 15, and that gives us another solution which is 3, 5, 15, which together with 2, 4, 8 comprises the list of all possible solutions to the initial problem. And now if you want to see another solution to this problem, as I said, you can check out Creative Math Solving's page on Instagram, linked in description. And if you're not following my page on Instagram, you are missing out on stuff, because I post Putnam problems over there as well, which don't make it to my videos. So if you're not following there, then you're missing out on some problems. And moreover, I also post self-made questions over there, which, as the name suggests, are made by myself. And they are problems, of course, which you won't find anywhere else, because I made them by myself. So if you like problem solving and you want to check out more problems, then you can go ahead and check out my page. Once again, link in description. And thank you for watching.
Turn up. Let's go.